Hey everyone, welcome back. I hope exam two treated you well. I'll be interested to read through those answers. If anything is confusing or you need help with anything, of course, always let me know. But this week, we're going to start talking about, and through the rest of the semester, really, just for the next month, we're kind of coming to the end of it. We're going to talk about grasslands today, and each week we'll have kind of a different biome that we'll focus on. So today we're thinking about grasslands. We'll go through a quick introduction on grasslands, think about the particular disturbances, both kind of the quote unquote natural disturbances and anthropogenic disturbances in grasslands, and then think about recovery succession in grasslands. So grasslands are a biome where grasses are the dominant life form, pretty simply as that. So this map shows the world's grasslands characterized using a land cover classification scheme from the International Geosphere Biosphere Program, or the IGBP. So the map distinguishes 6 grassland types: non-woody grasslands, open shrublands, closed shrublands, savannas, woody savannas, and tundra. According to that map, approximately 13.8% of the global land area, that's excluding Greenland and Antarctica, is woody savanna or savanna. 12.7% is open and closed shrub, 8.3% is non-woody grassland, and 5.7% is tundra. So approximately 40% of the terrestrial area of Earth is grassland. And that comes out to about 52 million square kilometers, which is right in the range of previous estimates. Previous estimates have been between 40 to 55 million square kilometers. So this map is similar. It's the same IGBP classification, but it's a slight variation that focuses on agriculture. So here we're looking at grasslands that are altered by a certain degree of agricultural activity or agricultural mosaics. They're differentiated from other grasslands. So when agricultural mosaics are excluded from the total area in grassland, global grassland area decreases by about 7 million square kilometers. Remember, the estimate was in the 40s, 40 million square kilometers. The decrease in grassland in sub-Saharan Africa is the largest, about 3.5 million square kilometers, though South America and Asia also have big areas where grasslands have been considerably altered. And you've seen this probably in other classes. I remember we went through it when we're thinking about forests. But everything that's circled in yellow is kind of a grassland, right? Including some deserts. So deserts are dominated by grasses. They're dominated really by open ground cover, bare ground. But where there is life, if it's not a cactus, it's oftentimes a grass. So oftentimes deserts are included in grasslands, but we have the steppe, we've got dry tundra. Most of these areas, again, if it's not forest, it's grassland. And in your mind, if you were to close your eyes and picture a grassland, I put a picture on this next slide of classic grassland, right? Oh, that's not what most people think of, right? Most people are just thinking about the grasses themselves. But of course, remember that grasslands are amazingly rich in diversity. Lots of forbs, lots of flowers. People who are really, really interested in wildflowers often go visit grasslands because those wildflowers live in grasslands. So keep in mind that when we're talking about grasslands, we're thinking about this very rich, diverse ecosystem. But of course, it's an ecosystem that's easy to convert to other things. We have conversion to agriculture, conversion to cities, general fragmentation into different parts, degradation, not necessarily changing the grassland into something different, but just degrading the quality of that grassland. And then aridification. Aridification is becoming significantly detrimental to grasslands, particularly in Africa. The Saharan desert is expanding as climate gets hotter and drier, and we divert water from some of these landscapes. So aridification also a danger. This table, is pretty outdated. So we're looking at like a 20-year-old table. So you can imagine that these figures are going to be probably even significantly higher than what they were 20 years ago. But it looks at the amount of land that's remaining in grasslands that has been converted to croplands, converted to urban areas, and then the total converted. But if we were to focus just on that total converted, we can see that North American tall grass prairie in the United States, we've lost about 90% of that tall grass prairie. In South America, particular woodlands and savanna, 76%, Asia, 21%, Africa, 20%, and then oceanic, Australia, woodlands and shrublands, 39%. So North American grasslands have taken a hit, which is not news to you. Now, so let's think about, we just talked about kind of like grasslands are endangered, right? And now we're going to switch into disturbance in grasslands. But let's first think about these disturbances from in the absence of humans. So quote unquote natural disturbances. And fire, just like forests, fire is an important natural disturbance in prairies also. We have only recently begun to really appreciate how significant of a role fire plays in forest systems. Similarly, we've only recently begun to appreciate how significant fires are in prairies also. Grazing is also a natural disturbance in grasslands. Of course, we've had in North America, there have been grazers for long before bipedal humans showed up on the scene, right? So we have bison that exist today, significantly reduced in numbers and range than what they occurred previously. In the past, you could see this map shows the historic range of different types of bison, different subpopulations, and they ranged from Florida all the way up through Alaska. Amazingly huge range. But if we think even further back in the time of saber-toothed tigers, there were these big grazing animals that were disturbing these grasslands. So these grassland species have evolved with grazers for a significant amount of time. Some research over the past couple decades has indicated the role that grazing plays. So this research is from Alan Knapp, who's here at CSU, and him and his team of researchers were looking at the interaction between grazing and fire. And so this image, we'll go through a figure here in a minute, but this is just an image from their research plots. And it shows grazing by bison increases spatial variability in the tallgrass prairie. So immediately after the fire, which is in April in that top image, in these grazed watersheds on the Konza Prairie, this is in Kansas, a native tallgrass prairie in Kansas, the uneven consumption of fuel by the fire, you can see how patchy that landscape was, that uneven consumption of grass and fuel by the fire in the grazed areas, in that upper photo, is caused by the patchiness of bison grazing from the previous year. So bison graze some places, and then it burns in other places. Those dark areas are where the bison did not graze so much, or where the grazing was light, and those fuel loads, the amount of grass, was therefore sufficient to carry a fire through that patch of land. Those lighter areas are patches that were grazed repeatedly by bison. So the amount of grass and the fuel loads was too low, and the impact of the fire was pretty small. Interestingly, later in the season, the bison graze preferentially in the recently burned watersheds, in those recently burned areas. And in this late spring view, this apparently is from late spring, the bison, the unburned watersheds can be seen in the background, so full of grass and just significantly different than if you had both grazers and fire. Now here's, I know this is a pixelated image, but that's kind of how it's from a satellite view, a remote sensing project from this kind of the same project. And this shows spatial variability, variability in grass type, variability in forage, variability in fuel loads, just basic variability across the space, across this landscape. And in the bottom graph, it shows the change in the spatial variability through time between the ungrazed and the grazed. So in the ungrazed area, The ungrazed area before the experiment was started was more variable than the grazed. But over time, the spatial heterogeneity of the grazed landscape increased and far surpassed that of the ungrazed site. So that the takeaway there being that variability is important and nature is variable. So things that increase variability are often seen as good. So the fact that grazing increases variability generally is a good thing. All right, another disturbance, moving on from foragers, is ants. I never think about ants from a big landscape ecosystem perspective, but they're a huge, incredible disturbance agent on grasslands. They can create, you can see in this image, this huge mound is an ant nest. There must be some huge network of tunnels underneath the ground, underneath this nest. And here you can see this sort of mounded sand one that is a little more typical what I think of. But if you go to, if you walk through grasslands, often you'll interact holes in the ground, big mounds from ants. The amount of earth that is moved from these ants is pretty striking. Of course, there are other things burrowing underground. So we've got groundhogs, prairie dogs around here. In that image on the right, you could see like a buffalo wallowing in kind of a mud pit. There's plenty of animals around the world that will intentionally paw at the ground and create and maintain these mud pits, which is a huge, of course, disturbance. It's pulling vegetation away. And so you can think about all of the disturbance successional processes that must happen after these disturbance events. Some of these are small disturbance events, some of them are large, but everything we've talked about in class will certainly be involved in the succession following these disturbances. And we can talk about fire again, but fire in an anthropogenic disturbance way. This could be either intentionally creating more fire or removing fire from the landscape. Often, certainly in forested ecosystems, it's the removal of fire that we think about in terms of disturbance, but sometimes in prairies, fires are intentionally burned every single year for agricultural reasons or otherwise. And so it could be either the removal of fire or the increase of fire that simply changes the disturbance processes on that landscape. And I've put this in a little differently. So the next disturbance that we're talking about here is livestock. And I've put livestock differently than grazers because this is the actual impact that the animals themselves might have on the land. Now, of course, they're grazing and there's the disturbance from the actual eating of those plants, but there's also the impact of them walking around and preferentially eating some species over the other, but also just like walking around and kind of messing with the landscape a little bit. This lower photo shows probably an overgrazed, overstocked chunk of land that's led to significant erosion. The image there with the goats in the trees and down from the trees, there are disturbances from these animals that go beyond just the eating of the plants. And this is really, you in other classes you might have heard, and if not, I'll explain it now, the tragedy of the commons. The tragedy of the commons, this livestock on public lands is a classic example of the tragedy of the commons. So, tragedy of the commons. If you are an agricultural individual with some livestock, you know that if you put one more animal on your land, it's going to decrease the health of that landscape if you're above the amount of animals that that landscape can hold. And it'll be negatively impactful on you if you do that. And so on your own land, you might choose to not put extra animals. Even though you might get a little extra money because of that extra animal, it'll impact all the other animals negatively. It'll decrease the health of your land. But if it's a public land, often the theory goes that individuals will do something that they know is negative for the common good because it benefits them personally. It works out in sort of a cost-benefit ratio because it benefits that individual while spreading the cost out among everybody else. So even though it costs them a little bit in terms of that negative impact on the land, that negative impact is spread among everybody else. And so everybody ends up making those same decisions. I'm going to put an extra animal on the land, and we all share the cost, the burden of that. And so that's the tragedy of the commons, and it's a livestock grazing is a classic example of the tragedy of the commons. And then sticking with anthropogenic disturbances, one could make the case that the loss of key species on the grassland is the result of human impact. There's this interesting correlation between this mass extinction event that North America saw and the arrival of Homo sapiens, because we hunted them all, right? We hunted the predators because we were competing with them, and we hunted all the grazers because we ate them. And so there used to be a lot more animals grazing the North American grasslands and grasslands across the whole world that just don't exist anymore because humans killed them, humans got rid of them. So the loss of species is also a disturbance, similar to kind of the loss of fire. You're just changing the disturbance regimes. And then we can't talk about anthropogenic disturbance without talking a little bit about pollution or eutrophication, the increasing role of the increasing amounts of nitrogen on our landscape. So pollution, we can think about just the actual pollutants that we're putting into the air, like extra ammonium, deposition from like kind of dirty rainfall that comes through a system and picks up all that kind of pollution from cars or whatever, deposits it elsewhere. But we also have significant nitrogen deposition from all of our agricultural activities like feedlots. There's interesting research out of CSU showing that those wind movement picks up nitrates from Greeley, all the dairies that exist out in Greeley. The wind actually picks up a lot of nitrates from that cow manure and then cycles around and deposits them up in the mountains. So there's an entirely new nitrogen depositional regime happening in these ecosystems because of anthropogenic activities. Super, super interesting. All right, and then our last one, the introduction of exotic species, certainly an anthropogenic disturbance. We bring species from all over the world, sometimes on purpose, sometimes on accident. On purpose, we might bring them, plant them intentionally into a garden. On accident, they might stow away on ships or in cargo or freight, and then accidentally, or wheels of tires, and then actually get introduced to a species. And that's certainly a big disturbance on our landscape. And you can see in this image of North America, here we've got tundra down into this typical grassland. There's a significant amount of percent of non-native plant species in some of these areas. California, their grasslands apparently have over 20% of those grasslands are non-native species, which are pretty high. And it's not uncommon to go to some fields, certainly in northern Colorado, and see a grassland entirely dominated by European pasture grasses, for instance. All right, so for the remaining time, just a couple more minutes. This video is a little longer than the others, I know, sorry. But just for the last couple minutes, let's think about how these systems might recover following a disturbance. And we'll compare two theories. One is going to think about large-scale disturbances, which is what this slide does, and then we'll think about small-scale disturbances. So for large-scale disturbances, you might hear literature or in classes of an old field model. So an old field is a field, an agricultural field that we no longer use. So it's focusing on, it's the study of succession in grasslands using abandoned cropland as kind of this model system, just to look at what happens to this abandoned cropland as it transitions back into its native grassland. And we know that there's distinct patterns in this succession because there's a lot of research from both North America and Europe showing what happens. It goes through an annual forb phase, and then a short-lived perennial forb, and then grasses, and then perennial grasses. It's sort of this transition that we see replicated across space. And it's relatively fast also. So it might only take 10 to 15 years to reach what we might think of as a late seral community. What we know less about in terms of large scale disturbances is how succession operates on quote unquote good sites or non cropland sites. There's lots and lots of literature on croplands that are no longer used, but there's really little literature on native grasslands and what happens after a big disturbance comes through. So an opportunity to learn more there. Now that was kind of large scale across a whole field. How does that field get back to a native grassland? But there's also these small scale disturbances from gophers and prairie dogs, from big animals wallowing, from grazing, from fire. And these are more typical of gap dynamics from forests. There's a lot of literature from forests on like a tree falling in the forest, suddenly increasing light, increasing soil resources, and how succession operates in that gap dynamic. And people have then used that model, this gap dynamic model, to explain succession on small scales within grasslands. So it's thinking on a smaller scale, probably more meaningful scale, and people in the literature have proposed it as an upside down forest, because a forest, certainly like a tropical rainforest. Tropical rainforests have shallow soils, so most of the roots are on the surface. But then these huge, huge trees, right, grow way up into the sky. A lot of grasslands are the same, except in reverse. You got these small little grasses, but then their roots go way down into the soil, surprisingly deep into the soil. And so water and nutrients, forests aren't so different, but in grasslands, water and nutrients are the critical resources for determining community structure in grasslands. So light, in a rainforest, light is that primary driving successional factor that gets released when a tree falls over. But if there's an individual grass that dies out, it's more a release of water and nutrients as that critical resource that other organisms around, other plants, take advantage of. So we're tipping that tree upside down, and we see that it looks kind of similar, right? And when we think about if we were just to randomly take some of this structure out, so I'll go back. Here we've just randomly chosen one individual, and we say, boop, you just died. It opens up a lot of space, not only space, but all of those roots that were there. If that plant dies, it's not like the roots magically disappear. Those roots are still there, they're just dead. And dead roots are a really great source of carbon and nitrogen. So all the microbes in the soil start doing their thing, decomposing all of those roots and releasing nitrogen and carbon to the surrounding environment. And so new plants can move in and take advantage of those new opportunistic resources that have become available. So just like a tree falling in a rainforest opens up some light, the death of a grassland plant and the death of its roots in the soil open up water and nutrients for surrounding plants to take advantage of. And so these disturbances in grasslands are really similar, right, to the gap dynamics in these old growth forests. And when we consider that disturbance as simply the removal of a dominant individual, whether it's a tree or a mature grass plant with big roots, then we have this below ground gap, which actually is kind of the same as a micro old field. So we have this theory of old field succession over large scales. And in the small scale, we think about gap dynamics. And what we find out when we actually look at the processes taking place, we actually see that the recovery processes are really similar between the old field and the gap dynamics. It's really just a matter of scale. Anyway, that's grasslands. Super interesting stuff. Grasslands are really, really important. There's some wonderful videos that I'll try to link to on our Canvas page from Planet Earth and BBC, David Attenborough, etc. But I hope you're all well, and if you have any questions, please feel free to let me know.